This video is a review for Final Exam Part 1. In the algebraic expressions section, we have some scenarios that talk about a certain number of plates or rulers and how much they cost. Based on the words in the context, you have to figure out whether you should be multiplying or dividing to find the answer. With this one, we have 7,500 divided by x, and this one we have 25 times t. They give us the total amount of money, and if we can figure out how many rulers, we can find out the cost of one. So I think it's helpful to plug in a sample value and kind of work backwards. For example, if you bought 10 plants, 10 times 25. If you bought 10 rulers, well, those are $750 rulers. Are you dividing or are you multiplying? Look at the context to figure it out. The next section has to do with words like sum and quotient and product. So sum means you're adding things together, product means you're multiplying, and quotient means you're dividing. So here, if we're saying the sum of the square of m, that's just m squared plus 9. If you're looking at the quotient of k and 7, that's k divided by 7. If you're looking at the product of 2 and the sum of 9 plus q, it looks like this. Since you're multiplying 2 and a sum, that's where we get the parentheses. They also tell us to evaluate if q is equal to 3, so we plug that in. And our new equation reads 2 times 9 plus 3, or 2 times 12, which is 24. Here we have a scenario with some numbers that matter and some that don't, and we're going to find out the missing value. So some unknown original population decreases by 36, and now it's 71. Turns out this 12 was just a distractor. What we can do here is we can add 36 to both sides, and we can find out that this missing value is 107. Here we have an expression 2w plus 5c. They tell us w is the number of pounds of walnuts, and c is the number of pounds of cashews. So what we do here is we plug in a 2, because there are 2 pounds of walnuts, and a 3, because there are 3 pounds of cashews. And 4 plus 15 is $19. All in all, in this section, there's a couple of key things to remember. Sum means to add, product means to multiply, and quotient means to divide. If you're writing expressions, plug in test values to see what makes sense. If a question says to evaluate or find the cost, you can plug in the given values for the variable or variables and solve. Combine like terms. We can add together numbers, always. We know that 7 plus 8 is 15. We cannot combine those with letters. Numbers like 7 don't get mixed with 4x. You can't say 11x or 11. It just doesn't work. We keep all the letters separate. 2x plus 4x, we add their coefficients. We add 2 plus 4 and keep it together with a 6. We can't, though, mix together x squareds and x's because they have a different exponent. So you can't put these together and get 5x squared or something like that. Instead, we just look at their coefficients and we add those together. And that's the basics of combining like terms. The first 3 terms here are all number terms. If you add them together, you should get 8. And then we keep the m separate. If there is a term that does not have a number in front of it, that means it's a 1. So 1p and 4p can be combined to 5p. P squared is different because it has an exponent of 2, so you can't mix it with the others. Again, y has a 1 in front of it, and we can only mix together the same letter. 2 plus 9 is 11x, and there's only the one y. Sometimes we have to distribute first. Here we have 7n minus 7 plus 3n. The n terms can be combined, and this gives us 10n minus 7. You only add the number in front of the letter. What happens if we're taking 14x minus 14x? Well, 14 minus 14 is 0. 0 times x just goes away completely. A lot of students like to leave the x there. That's not correct if, when you're adding and subtracting, you get 0. Let's start with the highest term exponent, c to the 4th. We have 7 minus 5 is 2c to the 4th. Next up, we have c, 7 and 3, so we'll add those together. And finally, we have minus 2. 4 notes for combining like terms. We're going to distribute first, like in this problem here. After that, we combine like terms. We always combine all of the constants, so think about the number terms, even if they look like fractions or squares or square roots. The number is always to go together. When it comes to variables, you only combine those that have the same exponent. So looking over here, we see p and p squared, they don't mix. C and c to the 4th, they don't mix. And x and y don't mix. Have to be the same letter and the same exponent. Finally, zeros cancel out. If you take a look here in the bottom left, 14 minus 14 is 0x, which just goes away. Let's look at all of these one-step equation problems. The goal is to get x by itself. So there's one other thing there, like a plus 3. We want to cancel out, so we do minus 3. To keep this equation still equal, I have to minus 3 once on both sides of the expression. That allows me to cancel out, and I have x is equal to 2. If there's a minus 2, we're going to plus 2. Since I do it on both sides, the equation remains equal, and we now have x is equal to 10. If there's a 3x, that means multiplication. To cancel that out, I divide. I have to do it on both sides. I get x is equal to 3. If there's a division symbol or a fraction symbol, to cancel that out, I'm going to multiply, and I have to multiply both sides. Here, x is equal to 8. To cancel out a square, I take the square root, and I have to do so on both sides, so here I get 3. If there's a square root, I have to square both sides, so here I get 16. This one would be minus 2.7 on both sides, because originally I have a plus something, so to get it by itself, I have to subtract. Remember that since we're starting negative and subtracting, we go further negative. This next problem has subtraction, so to cancel out subtraction, I add, and I do the same to both sides. This gives me x is equal to 38.4. Even though there's a negative there, this really means negative 4 multiplied by m is equal to 44. To cancel that out, I divide by a negative 4 on both sides. Since I have a positive divided by a negative, my answer comes out negative. Here I have h divided by 3. To cancel that out, I'm going to multiply by 3 on both sides. 15 is equal to h. This one's different because I have x on the bottom, but the steps are the same. You multiply by whatever's on the bottom. Over here it cancels out, and I have 15 is equal to 5x. I'm not quite done, because I have to figure out what x is all by itself. This gives me 3 is equal to x. When there's a 1/3 in front of x, you can think of that as x divided by 3 if you want to. Sometimes that makes it easier to understand what to do. You can also think of it as if I multiply by 3, on the top, 3 and 3, well, cancel out. So then on the other side, I'm left with negative 3 over 3 is equal to x, or negative 1 is equal to x. To cancel this out, I take the square root, so 5 is equal to x. To cancel this one out, I square both sides, so x is equal to 16. So the tip here is to ask yourself, first of all, where is the variable? Start on that side. What operation is happening? Am I adding, subtracting, multiplying, or dividing? That tells you what to do to cancel out. If there's a square, you square root. If there's a square root, you square. When we have fractions like this, or the letters on the bottom, it's a little bit trickier to see. But you multiply by whatever's in the bottom of the fraction, and think of multiplying by 1/3 as the same thing as dividing by 3. Next up is two-step equations. So let's talk about how you figure out the order. Let's say, for example, that you were told x is equal to 7, and we were just looking at this part over here. You would take 2 times 7 plus 5. The first thing you would do is multiply, and the second thing you would do is add. That's called following the order of operations. If you want to undo this, we follow the reverse order. First, we subtract, and then we divide. And that's the order of operations in reverse. So for this particular problem, we can minus 5 from both sides and get 14 is equal to 2x, then divide by 2 from both sides and get 7 is equal to x. And that's the number that makes this equation true. Keeping with that same idea, here we can add 15 to both sides. This tells us that 16 is equal to negative 4x. We divide by the number in front of x, and negative 4 is equal to x. For this next one, you could divide both sides by 3 and then subtract 2, and you would get x is equal to 4. I think a lot of people like to distribute first, in which case you would subtract 6 and then divide by 3, and you get x is equal to 4. Two different ways to solve the same problem. If you're comfortable distributing first, go for it, but you don't have to. First, you undo the subtraction. Remember that x over 2 is going to get close, this part is going to get closer to 0 since we're adding, and we're going to multiply by 2 on both sides, so we get x is equal to negative 16. First, we minus 12 from both sides. X squared is equal to 36. Then we take the square root of both sides. X is equal to 6. First, we minus 1 from both sides. We have 6 is equal to the square root of x. Then we square both sides. 36 is equal to x. We solve this one like normal, where we add first to undo the subtraction. We have 2x is equal to 8.8. And if we divide by 2, we get x is equal to 4.4. Sometimes on the SAT, they ask you not to find x, but x plus 2, which is just 6.4, because we take our original answer and then we add 2. First, we subtract 1.5 from both sides. We are going further negative here. We divide by negative 3. We have 2.3 is equal to x. If we want to find what double that is, we multiply by 2, and we have 4.6 is equal to 2x. So the order of steps that we take are generally to add or subtract things first, then multiply or divide, and squares or square roots are next, and then parentheses. If you think about the order of operations, PEMDAS, this is the reverse of the order of operations, because we are working backwards to figure out what the variable is. Here are some tips for solving multi-step equations. Number 1, distribute and combine like terms. This will clean up your equation. It will simplify things. You'll have less there, and you'll avoid some of those mistakes that are often made because there's so much going on. Number 2, some of these equations have variables on both sides. You have to change that. You have to add or subtract until variables are only on one side only. After that, you'll have a 1 or 2 step equation like we've been looking at. So here there's nothing to distribute or combine in terms of like terms. So we're going to take a look at, I have an x and a 2x. I need to cancel out one of those. What does that look like? We're going to add or subtract. So I'll do minus x and minus x. And over here is 0x plus 3. And here is 1x minus 7. Did you know that 0x can just be removed? You can't leave an x there. You have to get rid of it. Now we're back to a one-step equation. We add 7 to both sides. We have our answer. X is equal to 10. Here's one where we have to distribute first and combine some like terms. 4x plus 12 minus 9 is equal to 27. 12 minus 9 can be combined. They're both numbers and they're on the same side of the equal sign. So this gives us 4x plus 3 is equal to 27. Now we're at a two-step equation. It looks a little bit easier. We have simplified things. We cancel out the addition first. So we have 4x is equal to 24. And then we cancel out the multiplication by dividing by 4. Final answer, x is equal to 6. So if we wanted to, we could try to get rid of these fractions. For example, if we multiply all of the terms by 4, we could do that. That would give us, 4's go away, 3x. 4 divided by 2 is 2. 4 times 4 is 16. Like that. Of course, you don't have to do it that way. You could instead choose to cancel out the 1/2. Then you could choose to multiply by 4. And finally, you could divide by 3. And there's your answer. But I do think that over here on the left, you get the same result with a little bit less work if you remember how this trick works. To cancel out some friendly fractions like 4 and 2, you multiply every term by the same number. Here I multiplied by the biggest number on the denominator. Two different methods to solve this one. So if we wanted to get s off the bottom of the fraction, we certainly could multiply both sides by s. Over here cancels out, and I have 2 is equal to negative 4s divided by 6. And I could work from there and multiply both sides by 6. This goes away. I have 12 is equal to 4s, or negative 4s. Divide by negative 4. S is equal to negative 3. If you don't like that method, I actually recommend using cross multiplication for this one. 2 times 6 goes on the left. You set that equal to s times negative 4, which is negative 4s. Notice that's the same thing I did over here. Sometimes it's easier to see it when you have those butterflies. And from there we'll follow the same steps and we'll get the same answer. This one at first looks to be quite confusing, but if we clean things up by combining like terms, things get a little bit simpler. We have 3x plus 43 is equal to 3x plus 15. One of the reasons I always suggest to deal with the letters first is if you subtract 3x from both sides at this point, you will get this. Don't panic. That just means you're done. Since these are not equal, you would write false, and the correct answer is that there is no possible solution. If you didn't combine those like terms and you just started moving around numbers, you're wasting your time. Always combine like terms and deal with the variables first. So here I'm looking at like terms. They have to be on the same side of the equal sign. So on the left I still have negative 3x plus 5, and here on the right I have negative 3x plus 5. Do you notice that they're identical? That's a pretty big clue, but if you didn't notice that, you could deal with the plus 3x first and get this, which is true, and that means you have infinite solutions. When the letters go away, what's left is either true or false. If it's true, infinite solutions. If it's false, no solutions. First step is to look at the letters. They're on both sides of the equal sign. That's a problem. So I want to cancel out one of them. Let's say I add 9x here. Then I have 24x minus 10 is equal to 2. Now I'm looking at a two-step equation. Cancel out the subtraction. And sometimes students here get confused because they think, that must be wrong. I must have things backwards. But no, it's 1/2. You always divide by what's in front of the x. First you distribute. You take the outside term, multiply by everything inside of the parentheses, and you get this. Then we look at, hey, there's a b value on both sides. I have to fix that. Let's subtract 1 to cancel it out. Let's say we subtract this one. We have negative 8 is equal to 2b minus 11. Now we're looking at a two-step equation. Cancel out the subtraction first, then divide. 3 over 2 is equal to b. I would also accept 1.5. So to add to those steps at the beginning, there are two special cases. If you deal with your variables first, and you're left with some numbers where it's a true statement, like 5 equals 5, then that means there are infinite solutions. If you are left with a false statement, like 43 is equal to 15, that means nothing will ever work, and we just write no solutions. For literal equations, we are rearranging, not solving. Still think in terms of the reverse order of operations. As we manipulate equations, we'll tend to add and subtract things first to cancel things out, then multiply and divide, then deal with squares and roots, and then finally parentheses. Keep in mind if you have something like 2x plus y over z is equal to q, that there is implied parentheses that go along with the top part of that fraction. So that means that step will happen after we multiply by z. So first, let's remind ourselves of our target. What is x, w, g, m, or j? That is the letter we're going to solve for. We're trying to get that letter all by itself. So here, we're trying to get x all by itself. That means we have to get rid of the y. When two letters are next to each other, that implies multiplication, so we divide both sides by y. On the left, y over y cancels out. What is q divided by y? Very simple. It's q divided by y. Here we want w. It's not by itself. There's an L there that we need to undo or cancel out. And the fraction bar implies division, so what we do is we multiply. L over L goes away, and what is b times L? Well, it's BL. The first thing to think about is that implied on the top of the fraction are parentheses here. So the first thing we're going to do is multiply both sides by 3y. What does this do? It cancels out the 3y on the right, because we're trying to get x by itself. On the left, how do we write this? Well, we can just say 3yt. Since it's all multiplication, we just stick them right next to each other. Since x is still not by itself, I have to subtract 2. What is 3yt minus 2? Well, you don't actually have to answer that because they're not like terms, so you just write it out like this. If you want to get g by itself, it's a little bit more work because we have to move it to the top of a fraction first. Multiply it by g to cancel out the division of g. Now we have gc is equal to f. When you put the two letters next to each other, that implies multiplication. But we need to get rid of the c by dividing, and we have g is equal to f over c. So we just kind of switched the c and the g. If you want to get m by itself, remember that these are implied parentheses, so we're going to deal with that later. And the first thing we're going to cancel out is the division of 3 by multiplying by 3. So we have 3q on the left, this goes away, and we have m plus 2c plus z. Now let's just go ahead and subtract 2c and z at the same time, why not? On the left, what is 3q minus 2c minus z? Well, it's just that. All this cancels out, and we are done. To get j by itself, I'm going to multiply by what's on the bottom of the fraction. So I have 2pk is equal to j. The most difficult part about literal equations for many students is they're not sure where to start, or that it doesn't look like normal. Remember to always start with the letter you're solving for, and look at that side of the equal sign, and think about these steps, the reverse order of operations. Do them one at a time to cancel out anything that's there. Don't forget to add the parentheses for things on top of the fraction. And if you're trying to solve for something on the bottom, you have to move it to the top first before you can do anything else. Absolute value can be defined as distance from 0. So between 0 and 7, there's a distance of 7. But between 0 and negative 7, there's also a distance of 7. So if we use those brackets, the absolute value of 7 comes out positive, but the absolute value of negative 7 also comes out positive. That's why sometimes there's two answers, because we have the positive side and the negative side. There's also the possibility that some answers are going to be impossible. The absolute value of anything will never be like negative 3, for example, because no matter what, it's going to come out positive. Distance cannot be negative. So for a basic problem like this, there are two answers, 14 or negative 14. Either one of those represents a distance of 14 from 0. And down here at the bottom is an example where there's no possible solution. Absolute value will never be negative, since a distance from 0 cannot be negative. To solve some of these other ones, you have to think about this bracket as being the target that we're trying to solve or get by itself. Like normally we solve for x, we're solving for these brackets. So that means we're going to minus 5 first. We have negative 3 times the absolute value of x plus 1 is equal to negative 3. And we're going to divide by a negative 3. This gives me that the absolute value of x plus 1 is equal to 1. A lot of students mess up at this original part because they think there's a negative 3, let me distribute. Well, these are not parentheses, they're brackets, so you can't actually do that. Instead, we think about those order of operations in reverse. We undo the addition, then we undo the multiplication. At this point, we split our answer, and we have a positive side and a negative side, because we can work on both sides of 0 here. And this is when the brackets disappear. We rewrite the x plus 1 equals on both sides, and on one side we put a 1, and on the other side we put a negative 1. And then we solve these separately. So here, one possible answer is x is equal to 0, and another possible answer is that x is equal to negative 2. Those are two values that make this equation true. Keep in mind that we are trying to get this by itself, so first we'll plus 5. 2 times the absolute value of x plus 7 is now equal to negative 7. If we divide both sides by 2, we get that the absolute value of x plus 7 is equal to negative 3.5. Doesn't matter though, because it's a negative, so at this point we're going to say no solution, because anything inside the absolute value bracket will never be negative. Here we're going to add 3 to both sides, and we have the absolute value of x plus 2 is equal to 3. We can split this, so I'll have a positive side and a negative side, because that's how absolute value works. It's distance from 0, distance to the right, and distance to the left. At this point, the brackets disappear. I write x plus 2 is equal to on both sides, and here I put a 3, and here I put a negative 3. I solve them separately. X is equal to 1 is one answer. X is equal to negative 5 is the other answer. The last one, if I add 5 to both sides, I have 3 times x minus 3 is equal to 0. If I divide by 3, I still have 0. And this is the other case where you will only have one answer, because you don't have a right of 0 and left of 0 answer. You only have 0. So we can simply write x minus 3 is equal to 0, add 3 to both sides, and we get 3 as our answer. So we're still using these reverse order of operations. We're remembering that oftentimes there are two answers, the positive side of 0 and the negative side of 0. Inside the brackets, they both come out as positive. The first thing that we solve for is whatever's inside the brackets. The stuff outside we have to cancel out. Whatever's in front we don't distribute. Remember, that means multiplication that we were undoing. And if we ever get a negative, like negative 3.5 or negative 14, we know that there's no possible solution. A ratio is a fraction like 1 over 2. If I set that equal to something like 2 over 4, that's another ratio. And you'll find that these two ratios are equal to each other. That is what's called a proportion. And we can use these proportional relationships to make predictions about different dimensions or different phenomena. For example, if I set up red on top and blue on bottom, and I have 4 red for every 3 blue, how many red will I have for 30 blue? So I can put an X there if I want. And this is the proportion I'm trying to solve. You could notice that you're multiplying by 10 here, and do the same thing to the top. The answer is going to be 40. If I put 40 in here for X, now these two ratios are proportional. One is just 10 times as big as the other. Think about the ratio, and let's put baseball on top and soccer on bottom. And then the 5 to 3 would be 5 over 3. Baseball, soccer, 5, 3. To set that up, I'm told I have 9 soccer players. So what do you think? Should I put the 9 on the top or the bottom? It has to be the bottom, because that's where soccer players go. And then I have an X here. You might notice the pattern that we are tripling. So this should be 15. This one's a little bit different, because if I tried to say boys to girls, and I set that as 2 over 5, they don't tell me anything useful in the other part. 35 students, where does that go? Does that go with boys or girls? I don't know. So I actually can't use that type of ratio for this one. Instead, I have to think about, well, if there's 2 for every 5, let's compare boys to the total. And that's 2 out of every 7. Where did that 7 come from? I added together 2 and 5. This works because now 35 is also a total. So then I can figure out how many boys. That's going to be 10 boys. But they ask how many girls. So that's the other 25. What did I do there? Times 5 times 5. Subtract from the total. With dimensional analysis, you are multiplying by a series of scale factors to figure out your final answer. I know that I need to cancel out and convert from minutes to hours, so I want to have minutes on bottom and minutes on top. Let's do the same thing with 24 hours per 1 day. I can cancel out hours now, and then we can say times 7 days per 1 week. Now days are canceled out, and I'm left with pages per week, and that's what they want, pages per week. So I just multiply across the top, across the top, 20 times 60 times 24 times 7 gives me 201,600. I could set up a proportion for this one if I wanted to. 2.5 ounces of chocolate is in one muffin. How many are in 32 muffins? If I multiply by 32 on the top, same as I did on the bottom, I have 80 ounces of chocolate. Now I need to convert that 80 ounces into pounds. It's 16 ounces per pound, so I can take 80 divided by 16 is equal to 5 pounds. Across the top, I did times 4. Across the bottom, I did times 4. That's 36, to keep those ratios equal. Across the bottom, I did times 5. So what number would I have to do for what times 5 gives me 15? The answer is 3. This is where that pattern starts to break down. And instead, what do? Is I cross multiply. 3 times 3 is equal to x times x. If you forgot what x times x is, it's x to the second power, because this is like x to the first times x to the first, and we combine. To solve that, we take the square root of both sides. This tells me that 3 is equal to x. This sort of cross multiplying can be a little more confusing if you don't write it correctly. That's how you write it. You keep the x plus 2 inside of parentheses, and you put the 6 on the outside. The other is 2 times 24. Let's go ahead and distribute this. We have 6x plus 12 is equal to 48. Now we're down to a two-step equation. Minus 12 from both sides, 6x is equal to 36. Divide by 6 on both sides, x is equal to 6. For ratios, the most important part is figuring out your pattern. If you can do red to blue for the original and your new population, that'll work out great. Baseball to soccer, making sure that baseball numbers are all on top, soccer numbers are all on bottom, that'll work out great. If you try to do boys to girls, but they give you total, that means you have to start with a different ratio. And if it's 2 to 5, you can also think of that as 2 out of every 7, total. From there, you have to pay attention to what you're trying to find, boys or girls. When it comes to proportions, sometimes we can just look at the scale factor. Other times, cross-multiplying is the way to go. When it comes to unit conversions, be careful to cancel out the correct units as you multiply. Scale factors can work pretty well if we're looking at this proportionally. We start with basic part whole percentages. So if I wanted to find 75% of a number, I can think of 75 as a ratio, 75 per 100. And I can compare that to some unknown value out of 60. So the unknown value is the part, the 60 is the whole. The 75 is the percent out of the whole, 100. And from there I can cross multiply to find the answer. 75 times 60 is equal to 100x. If I cross multiply and solve, I get 45, which makes sense because if I take 45 divided by 60, I get 0.75, which is the exact same thing I get for this ratio. They have to be the same, 0.75. The tricky part is setting it up. Look for the word what, look for the word of. What tends to be where your x goes. Of tends to be where our fraction bar goes. So 15 over 60 is what we write here, and we don't know the percentages. So we're going to put an x over 100. If I cross multiply 15 times 100, I set that equal to 60 times x, and I get that x is equal to 25. If I want to test my work, I can take 25 over 100, and I can take 15 over 60. I should get the same decimal equivalent for both of them. For this one, I could take 100 over 100 is equal to some value over 22.52. This is a bit of a trick question, though. 100% of anything is just equal to itself. So we already have our percentage, 20 over 100. Do you think the 9 should go on the top or the bottom? Top, because of tells you where to put the fraction bar, and the what number part is the x, so that goes in the bottom of the fraction. That means 900 is equal to 20x. If I solve that, I get that x is equal to 45. To test this, I could take 20 divided by 100 and see what decimal I get. Then I could take 9 divided by 45 and see what decimal I get. They're the same, so I did it right. 25%, I'll write as a fraction, of what number? That means it goes on the bottom. After I cross multiply, I get this. If I cross multiply and divide, I get that x is equal to 500. To test my work, take 25 over 100, see what you get. Take 125 divided by 500, see what you get. They have to be the same, otherwise you messed up. This one is missing the percentage. That tells me that x goes over 100, and then the of tells me that 25 goes on the bottom. It doesn't really matter which side you put the 25x on. You could put it on either side, as long as you set them equal to each other. If you take 7,500 divided by 25, you get that x is equal to 300. If you wanted to test your answer, you could take 75 divided by 25, see what you get, and 300 divided by 100. You should get the same. 15 over 100, that's the percentage part, is x over 180. Of is like the fraction bar, it tells you that the 180 goes below it. If I cross multiply and divide, I get an answer 27. To test my work, let's try 15 over 100. I'm going to get 0.15. Let's try 27 over 180. Do I get the same thing? Yes, 0.15. That means I did it right. So for the basic percentages, it's always part over whole. And one of your fractions is always going to be something over 100, whatever your percentage is. And if you're missing the percentage, then it's going to be x over 100. Cross multiply and solve, and make sure you check your answer. Because if you got it wrong, meaning that these two ratios don't equal, that probably means you have to look about flipping from the top and the bottom. For a percent increase and decrease, let's consider a scenario. The number 60, if it's increased by 15%, is 69. There's a couple ways you can go about doing that. You can take 60 times 0.15, and that gives you 9. And then you can go ahead and add that to your original, and you get 69. But it turns out you can also multiply by 1.15, and that gives you straight to your answer, 69. So how do we figure out this number right here? It's 100 plus 15 divided by 100, and we convert it to a decimal. If we're starting from our original and we're going to our new value, we multiply by 1.15. Let's look at a decrease example. If we have the number 80 decreased by 20%, we get 64. One way to do this is we can take 80 times the decimal equivalent and get 16. And we can take 16 and subtract that from our original value, and we get 64. It turns out, though, we can also multiply by 0.80. How do we get that? We take 100 minus 20 divided by 100. And this will give us straight to our answer, 64. So for both of these, if we're going from original to new, we take 100 plus the amount we're increasing divided by 100, or 100 minus the amount we're decreasing divided by 100. And what this allows us to do is to jump to the answer in one step. Instead of finding 15% and then subtracting or adding, well, this would be adding. Instead of finding 20% and then subtracting, we can go directly to the answer, because 80% of the original will give us the result after a 20% increase, and 115% of the original will give us the answer after an increase of 15%. So if we think about original and new, did we increase or decrease here? We went down. So if we start with new divided by, I'm going to say old just because it's shorter, we can find out a decimal. That decimal is 0.85. If I think about starting from 100%, what percent did I decrease? And the answer is 15%. If you wanted to break it down into steps, you could think of it as 240 minus 36 is 204. And what is 36 out of 240? That will give you 0.15. So we are reducing by 15%. Any way you do it, if you arrive that we have 85% of what's left, or if we reduce by 15%, they will tell you that same answer. It's kind of like before, where you can calculate it separately and add. Long story short, if you start with new divided by old, you will always get the resulting percentage, which, since this is 85, it's like 100 minus 15 is equal to 85% of the original. The actual answer is decreased by what percent? 15%. Here we take new divided by old, so that's 208 divided by 160, and we get 1.3. If we convert that to a percentage, that's like 130% of the original. That represents a 30% increase. Another way to think of it is we start with 160, we add 48, and now we're at 208. So what is 48 divided by 160? That's 0.3. We increased by 30%. Hopefully one of those methods will lead you to the correct solution. So if we think about these jeans costing $20, then we're decreasing by 20%. What's left? 80%. So we can take 20 times 80%. The decimal equivalent there is 0.8. And that'll give us $16. That's the new price. Here we can think about 19.99, and we're going to add 10%. If we do that, we're now at 110% of the original. So I can think of that as 19.99 times 1.10. Since that gives me 21.989, and we're talking about money, I think 21.99 is the great way to round it. Here we have a decrease, but when they give us $15, that is the price over here. That is 75% of the original price. So with these before, we were multiplying by 80% because we were applying the discount. Here, we're going to take $15 divided by 0.75 because we are working backwards to find the original. And that'll give you $20. So if you have the original and you're working forwards, times 80% or times 0.8. If you're trying to find the original price, you divide instead of multiply. This one is an increase, so some number plus 6% is 106% of that original number. And the resulting value is $40.28. Instead of multiplying by 1.06, we're going to take that 40.28 and we're going to divide by 106%. Or we're going to divide by 1.06, that's the decimal equivalent. That gives us $38. So if we are adding a percent, we multiply to find our new total. If we have the new total, we divide to find the original amount.